In an obscure corner of the universe, situated on a backwater arm of an unremarkable galaxy called the Milky Way, a fistful of planets wend their way around a rather standard-issue star. But take a closer look at the third planet out, and there it is. A restless blue planet with a red and violent soul. Powered by the molten rock that lies beneath, it explodes, slithers, jerks, and sloshes, and sometimes kills. Continents collide and shear apart again. Volcanoes erupt, mountains thrust skyward, and cities wait to die. All because of the liquid rock we call lava and its parent, magma. Journey back in time to the Earth's molten origins, then join the wild ride through the jigsaw puzzle of our past. Fly into our violently beautiful present and visit the explosive ring of fire. And contemplate, if you dare, the shattering nightmares the lava-driven world still has in store for us in the future. Mega tsunamis, mega thrust earthquakes, and the horror of the super volcano. Join us for a dazzling and dangerous excursion, past, present, and future, on a place called Earth, a truly amazing planet. Welcome to heaven, with a window into hell. This is the Big Island of Hawaii, home to Kilauea, one of the most active volcanoes on Earth, and perhaps the best place to see a planet's labor pains as it gives birth to itself. For the poet, this lovely, dangerous stuff oozing and spitting out of the volcano might suggest a glowing lifeblood pumped from the red heart of a hot and vital Earth. A more apt comparison might be a bad case of indigestion. This is a planet that belches, vomits, shudders, heaves, and passes gas. Really nasty gas. Whether from a pulsing heart or a heaving gut, lava is our only concrete glimpse into the Earth's interior, into an engine of creation and destruction that dwarfs all the mighty powers of the planet's human inhabitants. What lies beneath? We probably know more about the interior of the moon, the sun, and the stars than the heart of our own planet. So this red messenger is not only hypnotic, it's precious. Follow this lava back down the tube into its home, and you're soon in the giant molten sphere that takes up the vast majority of the Earth's volume. The mantle. Made of superheated rock so dense and hot that it moves like glowing taffy. The mantle churns in extreme slow motion. It's about 2,000 miles down before you hit the Earth's cores, and it may take millions of years for the molten round trip back up to the spewing spectacle that is Hawaii. For just a glimpse of what lava can do, drain away the ocean and sail by the Hawaiian island chain, all children of volcanoes. From south to north, the islands grow progressively and neatly older. The youngest is Loihi, now spewing lava, but which won't break the surface for another 50 or 100,000 years. Then there's Hawaii's Big Island with its 5 volcanoes, from seafloor to top as high as the Himalaya. The further north you go, the smaller they get, sinking and eroding over time, each one a little older than the last. And all of them, like all land on Earth, born of lava. What is immediately obvious is that lava creates paradise. Within months on the scorched new Earth, vegetation takes hold. The volcanic surface is rich with nutrients belched up from within. In just years, sun and moisture and microorganisms turn lava into soil. And life explodes. The gifts of the volcano have always lured humans onto its slopes. But what creates paradise here also creates mischief of unbelievable power elsewhere. Mount St. Helens in America, Vesuvius and Etna in Italy, Unzen in Japan, Pinatubo in the Philippines, a litany of awe and terror. Not just from volcanic eruptions, but from those other terrible powers of the lava-driven world. Earthquakes, tsunamis, landslides, and a whole slew of other deadly phenomena. Take a look at the places on the planet where volcanoes erupt and earthquakes shake, and suddenly the world looks like something stitched together by Dr. Frankenstein. But these are not sutures. They're wounds in the world where the planet is literally ripping itself apart and spewing up its guts. And other places where it is smashing together and eating itself alive. It is at these seams that the vast majority of earthquakes rage and volcanoes explode. Why is the Earth so restless? What causes the ground to shake violently? Volcanoes to erupt with explosive force, and great mountain ranges to rise to incredible heights? The answer is plate tectonics. Lava is simply the surface signature of the powerful engine that drives it. All that molten magma beneath the crust. The Earth's surface is broken up into a dozen-plus chunks of different sizes. Plates, all of which skate around like planetary bumper cars. The plates float despite their enormous mass, because there is denser material below. The continental parts of the plates are the lightest of all. Their granite-type stone, which may seem heavy enough to you and me, might as well be styrofoam compared to what lies beneath. A boiling pressure cooker of melted rock, magma. Most of the boundaries between individual plates cannot be seen because they are hidden beneath the oceans. Thanks to satellites and sonar, we know where they are and how impressive they are. Whisk away the oceans, and we see a long mid-ocean ridge where the Earth is tearing itself apart and spitting up some of the highest mountains on the planet. Here, plates move away from each other like a pair of conveyor belts moving in opposite directions. And new crust is created as lava wells up to fill the void. Much of this underwater oozing takes the form of pillow lava. As the hot lava erupts on the cold ocean floor, a rounded bubble hardens instantly. As more lava pushes out from inside the flow, the pillow expands. New pillows burst through as the pressure increases. Equally spectacular are the smoking chimneys to be found along the ridge. Water that has seeped into the seafloor is heated by all this volcanic activity and blown upwards. At the remarkable Black Smokers, water reaching temperatures in excess of 350 degrees Celsius jets out. It's thought every drop of water in the world's oceans passes through a hydrothermal vent about once every 3 million years. There is one intriguing landscape where the Earth is ripping itself apart, and you don't need a submersible to see it. you don't even need to get your feet wet. This is Iceland, where a mid-ocean ridge managed to beach itself on land. Here, the Earth stews in its own juices, much to the delight of humans, who welcome a dip into the geothermically heated spas that dot an often forbidding landscape of black rock and blue-white ice. Here, too, you can stand with one foot in America and one in Europe, geologically speaking, because here at these cliffs lies the dividing line between the two plates. If you stood here for 40 years, your feet would be about 6 feet apart. At the foot of these cliffs lie the Parliament Plains, Thingvellir, the site of the ancient Icelandic Legislative Assembly, a democratic institution founded more than a millennium ago. In this natural amphitheater, laws were proclaimed and trials held, then announced to the throng assembled in the valley below. A short way north along the cliff is Drekkingarheilur, or Drowning Pool, a crystal-clear pool of water where unfaithful women were drowned. This is one of the most geologically active places on Earth. Even under Iceland's spectacular glaciers, eruptions occur. And even seemingly placid pools of water tell of the grumbling violence that lies beneath the island. If you wait a moment, once the water starts to bulge, it's a good idea to take a step back. The word geyser is Icelandic, which makes sense. And if you missed it, wait a couple of minutes. Standing here where Europe and North America meet and looking east or west, you have to wonder what these plates are up to at their far edges. It stands to reason that if the Earth is spreading here, it's got to be colliding somewhere else. And it is, often fatally. Head about 5,500 miles east, and here's bustling Tokyo, smack above where the Eurasian plate hits the Pacific and Philippine sea plates. Let's try the other direction, about 4,000 miles west of Iceland. And here's the San Andreas Fault, where the American plate hits the Pacific plate and runs just offshore of San Francisco. Tokyo, San Francisco. What do these two places have in common? In geological terms, they are cities waiting to die. So how did we get to this place where many of our most storied cities are on the endangered species list? To answer that, we have to go back to the beginning. About 4.6 billion years ago, on the edge of a spiral arm of a pretty obscure galaxy, a lot of space rubble starts circling in a slow gravitational dance. These rocks and gas are the remains of several stars that exploded long ago. Perhaps about 100 million years later, this space junk begins to collect together under the force of gravity, lighting up from the energy of spectacular collisions. Planetoids smash into one another, causing some to shatter, others to merge. One planetoid will become the Earth. It suffers constant, cataclysmic bombardment and swells into a glowing molten ball. About 100 million years after the Earth began to form, a change, lava, literally the scum of the Earth at the time, the lightest part of the molten magma sphere, begins to cool and darken into a crust. For now, the crust will keep melting, but it's a start. Then something truly remarkable emerges. lighter blobs of the molten earth called cratons shoot to the surface and stick, giving rise to the beginnings of the Earth's permanent crust. Meanwhile, the lava of the primordial Earth's surface has been belching out water vapor and other gases. Eventually, the atmosphere gets so saturated with water vapor that it begins to rain in a continual downpour that drenches the lava for as much as 1,000,000 years. Flying past the Earth at this time, we see a vast gray ocean beneath a red-tinted sky, punctuated by volcanoes and small land masses. And unlikely as it seems, life may have gained a foothold already. That life in the oceans that gave birth to it may actually be vaporized many times by cataclysmic bombardments, which have slowed but not yet stopped. Earth has begun to take on its final form, a crust, a skin so thin it would be less than a sheet of paper were the Earth the size of a basketball. And under that, a molten semi-solid mantle that boils in extreme slow motion. And finally, two cores, a liquid iron core pulsing out a magnetic field that helps shield us from a deadly cosmic wind from our sun. And a solid nickel and iron inner core. By now, the remarkable process of plate tectonics has kicked into gear. Though how and when it started exactly, we do not know. For what follows next, you might want to strap yourself in. It's going to be a bumpy ride. Here's how it might have happened. At first, Cratons and one continent called had the planet all to themselves. Then, around 500 million years later, Arctica took shape. About another 500 million years passed before Atlantica formed. The continents roamed separately until, about 1.8 billion years ago, Arctica collided with what is now Eastern Antarctica to form Nina. Then Nina, Atlantica, and collided 1 billion years ago, forming the supercontinent Rodinia. After about 300 million years, the three landmasses separated and came back together in a new configuration, Pangaea. Pangaea came apart too. When Pangaea split, and Atlantica split up too. If you're confused, join the club. Even the Earth seems confused. All of this movement made for a host of unlikely neighbors way back when. North America's eastern seaboard once rubbed shoulders with Chile. California and Australia were neighbors, if not connected. And Brazil was either connected to Nigeria or very close. Run the Earth time machine backwards, and you can see why. But no matter how many times you run the demolition derby of the continents, a question remains. What the hell is driving them? Hell, apparently. The force driving the plates is the slow movement of the super-hot semi-solid mantle that lies below the rigid plates. Like hot soup, magma boils in slow motion. Superheated magma rises to the surface, begins to cool, and then sinks back down to the bottom of the pot, where it is reheated and rises again. This cycle is repeated over and over to generate what scientists call a convection cell, or convective flow. But where's the heat source keeping our earthy soup performing its circular gymnastics? Well, most of it is left over from the spectacularly energetic collisions and gravitational crushing that created the Earth to begin with. It's still trapped down there, and it wants it out. And there's something else in the molten depths that makes it pretty hot real estate. Radioactive material. The belly of the beast has plenty of uranium and other radioactive elements, all of which release heat as they decay. That decay has significantly slowed the rate at which the Earth is cooling. So what does this mean at the surface? Two things. First, magma being burped up along the ridges. Those places like Iceland where the Earth is tearing itself asunder is pushing the plates in their respective continents apart. Second, what goes on at the other end of those plates, the collision zone, may be equally important. Here, where the heavier plates dive under the lighter ones, yanked downwards by gravity, they haul along their plates back into the oblivion of the mantle. That's what we know, or what we think we know. But the details of what's going on in the deepest parts of the Earth that drive the engine of plate tectonics, we may never know. But what practically all scientists agree on today is that virtually everything on our planet is being shaped by plate tectonics, including the grand panorama of life itself. How momentous are these forces? A glimpse of the heady heights of Earth's most outstanding feature is most informative. These are the Himalaya, with Mount Everest their crowning glory. For those who attempt to climb it, it seems eternal, immobile, and mercilessly solid. But Everest and its Himalayan companions are creeping upwards even as we speak. Spectacular reminders that the demolition derby of the Earth's surface dwarfs any power that humans can generate. The Himalaya majestically lay claim to 96 of the 100 tallest mountains on Earth. And Everest, the highest of all, pokes a hole in the sky at 29,000 feet. High up on Everest, higher than the saner among us dare to go, you can find something fascinating: fossils. Fossils of sea creatures from the trilobite family. Some more than 500 million years old. How did they end up at the cruising altitude of an airliner? This dramatic episode of Earth's soap opera might be called When Continents Collide, and the result gives new meaning to the term upward mobility. Let's rewind Earth's history by about 175 million years. Something that looks suspiciously like India breaks off the southeastern tip of Africa and begins drifting north. Then, 50 million years ago, boom, the leading edge of the Indian plate, which is oceanic crust, slams into the continental Eurasian plate. When the two continents meet head-on, the crust buckles upwards. The Eurasian plate crumples over the Indian plate. The collision of the two plates over millions of years has thrust the Himalaya and the Tibetan Plateau to their present dizzying heights. And they're still growing. Where they will stop, no one knows. Global positioning devices planted on the summit show that Everest seems to be rising by 1.5 inches a year. And that's how those little ocean-loving trilobites got all the way up there. They used to live in the sea that India squeezed shut just before it rammed into Asia. Believe it or not, the Himalaya are hardly without precedent in the history of the Earth. Let's rewind the Earth back to about 450 million years ago. Remember Pangaea, the supercontinent? Well, just before it was Pangaea, it was two supercontinents. One named Laurasia, and the other named Gondwana. When Laurasia and Gondwana collided, the resulting mountain range may have been the greatest the world has ever seen, rivaling Everest and its brethren. In the wear and tear of time, erosion has since obliterated all traces of that mountain range's highlands. All that's left are the stubs, like worn teeth, in places like the Appalachian Mountains in the North American East. So much for when continents collide. But this is only the tip of the iceberg of our journey through earthly collisions. Sometimes continental plates smash into ocean floor plates. Sometimes seafloor hits seafloor. And sometimes plates simply grind against each other, like ships passing way too closely in the night. All to create topography as awesome as Mount Everest is tall. When the lighter continental plates crash into the heavier plates of the ocean floor plunges underneath, creating the very deepest parts of the oceans, its trenches. Let's drain the planetary tub once again and take a glimpse at the Pacific floor off South America. Here, the oceanic Nazca Plate is ramming into and surging under the continental part of the South American Plate. In turn, the lighter South American Plate crumples upwards, creating the towering Andes, the backbone of the continent. It's a dangerous backbone. Here, legendarily strong earthquakes rumble and killer volcanoes spew. In some places, of course, ocean plate inevitably converges on ocean plate, and the result is a catastrophic downward mating dance that creates devastating earthquakes. The Mariana Trench paralleling the Marianas Islands, for example, marks where the fast-moving Pacific Plate converges against a slower-moving Philippine Plate. The Challenger Deep at the southern end of the Mariana Trench plunges so deeply into the Earth's crust that you could flip Mount Everest upside down and fit it easily inside. Here, too, volcanoes are born. Over millions of years, the erupted lava has formed volcanic rock on the ocean floor that piles up until a submarine volcano rises above sea level to form an island volcano. Such volcanoes are typically strung out in chains called island arcs. The result of all the intricate plate tectonics fringing the giant Pacific Plate, with the attendant bounding and plunging and scraping, geologists call the Ring of Fire. And they aren't kidding. The ring quakes and explodes up through Java, the Philippines, Japan, and Russia, rumbles east along the Aleutian Island chain to Alaska, and then turns violently southward down the western coast of North, Central, and South America. Destructive earthquakes, volcanoes, and tsunamis all find a home in this Ring of Fire. So that leaves a compelling question. Where's an Earthling to go to find a nice, calm, geologically settled place to hunker down? Clearly not those places where the Earth is tearing itself apart and creating volcanoes and earthquakes. Or the places where the Earth is smashing together, creating often even worse volcanoes, earthquakes, tsunamis, and the like. Maybe we can safely retreat to the centers of the various plates and enjoy their quiet beauty and restful ways. The feel of solid, immobile rock beneath our feet, right? Wrong. Some of the scariest, most violent places on Earth lie smack in the middle of giant plates, which by all rights should just sit there, placidly ignoring what's going on at the faraway edges. And no one knows exactly why they don't. For a glimpse into what might be giving the nicely settled parts of the world major indigestion, let's return to paradise, Hawaii. It is thousands of miles from the Ring of Fire, right in the middle of the giant Pacific Plate, far away from the action. So how did it get here? Hawaii, it seems, is just the tip of the iceberg, or make that the Fireberg, of immense proportions. There are a handful of such places around the world, and like Hawaii, they usually make for benign and beautiful islands. They are called hotspots. But don't be lulled by Hawaii. There's one volcanic hotspot out there that's threatening to bring the world as we know it to an end. Like to know which volcano is going to make for great vacation pictures? Which might kill hundreds of thousands of people? Which one has the potential to devastate life on Earth, including perhaps us? It's time to dive into those smoldering, explosive flagships of the lava-driven world, volcanoes. So here we are, back in Hawaii, away from the hellish rims of the Pacific Ocean known as the Ring of Fire, where volcanic eruptions are catastrophically explosive and earthquakes can tear the Earth apart, level cities and hurl giant waves shoreward, taking hundreds of thousands of lives. Here, lava tends to seep and spit lazily out of restrained volcanoes. It eats everything in its path, including human habitation, but usually moves no faster than walking speed. Only rarely have Hawaii's volcanoes lashed out explosively. What's Hawaii's secret? It's a plume of magma, a hotspot rising from deep within the Earth's molten mantle that has somehow managed to break through the crust of the giant Pacific Plate. It has created in succession the islands of the Hawaiian chain until it reached here, under the Big Island and Loihi, the baby volcano that won't breach the surface for another 50,000 years at least. Because the Pacific Plate is moving northwest, but the hotspot itself stays put, each island is carried away as another one forms. But the magma under Hawaii, rechristened lava once it emerges from its tube, is running almost liquid. It's been flowing out from under the Pacific Plate for millions of years. Layer upon layer of almost flat lava fields, creating gently rounded volcanoes that have been slowly building up from the seafloor. These volcanoes are called shield volcanoes for their gently curved shape. Despite their tendency toward nonviolence, one must not underestimate the tremendous power of these shield volcanoes. Mauna Loa on the Big Island, quiet now but still stirring, is 13,681 feet above sea level, which means it rises more than 29,000 feet above the deep ocean floor. This magnificent geologic creature would be taller than Everest if much of it were not underwater. Hawaii's slow and steady wins the race attitude comes from that gentle lava, which comes in two forms, Pahoehoe and A'a lava. Pahoehoe is a smoother, ropey lava flow and accounts for most of the lava splashed out of its volcanoes. A'a is a chunky, rough, broken lava flow. Legend has it that A'a lava got its name from the noises barefooted people shouted while walking across its razor-edged, glass-tipped surface. It's only a legend. A'a actually means stony in the Hawaiian language. In human memory, the lavas of Hawaii have taken very few lives. Perhaps 5 in the last century. And about 100 people who happened to be in the wrong place at the wrong time back in the 1700s. Compare that toll to other volcanoes elsewhere. 36,000 killed by Krakatoa in Indonesia. The sound from its explosion was one of the loudest sounds humans ever heard. 30,000 killed by Palai in the Caribbean. Thousands more by Vesuvius and Etna in Italy. These are tolls directly from the volcanoes. This doesn't take into consideration the hundreds of thousands who died through the ages from even larger volcanoes that affected climate, decimating crops for years afterwards. So why is it that the volcanoes whose names reverberate through history went boom instead of bloop? Why is this so terribly different from this, or this, or this? Now those look like real volcanoes, and they'll kill like real volcanoes. They're cones. They smoke, they brood, and then all hell breaks loose. Welcome to the deadly splendor of the composite volcano, also known as a stratovolcano. Unlike Hawaii's shield volcanoes, which are flat and broad, composite volcanoes are tall, with steep sides, and they're violent. The steepness of their slopes hints strongly at their destructiveness. Other famous composite volcanoes include Mount Fuji in Japan, Mount Cotopaxi in Ecuador, Mount Shasta and Lassen in California, Mount St. Helens and Mount Rainier in Washington, Mount Pinatubo in the Philippines. Some slumber, some smoke, and some wait. Why? Lava apparently has a very different personality from place to place. And in some locations, it's positively explosive. This is the lava from Mount Unzen in Japan. Notice how it doesn't run or flow or splash or do anything that sounds remotely like fun. And here's Montserrat. Notice it just sits there. Chunky, glowering, bulging, and totally repressed. And if you asked it how it felt, it would say fine and turn away, seething and steaming. Even at high temperatures, it doesn't melt. It's too sticky. It bulges out into a dome, the smoking silo of a natural bomb. Apply more pressure from the Earth's mantle, and the lava shatters explosively, sending a plume of flaming ash hurling into the sky. And what goes up must come down. The ungodly return of the flaming ash to Earth is called a pyroclastic flow, a burning avalanche of stuff that's hotter than your oven and moving at the speed of a bullet train. It's what stopped time for the poor Romans of Pompeii, entombed by burning ash in their attempts to escape. It's what swallowed a Japanese town after killing some of the most experienced volcanologists in the world. It's also what left the capital of the Caribbean Eden called Montserrat in ruins. And the smoking volcano belches threateningly to this day. All around the world, stratovolcanoes like these are stockpiling their explosives, brooding and smoking, awaiting the moment when the magma below them lights the lava fuse and detonates. Unbelievably, despite the destruction and death toll such volcanoes have visited upon mankind, they are minor compared to the violence that the lava world may have in store for us. And now we get to the three great time bombs of plate tectonics that lie somewhere in Earth's future. The supervolcano, the megathrust earthquake, and the mega tsunami. On the day after Christmas in 2004, the world reeled at one of the worst natural disasters of all time, a huge tsunami. The cause of so much devastation? The most powerful kind of earthquake on the planet, a megathrust earthquake deep in the Indian Ocean. It killed almost 250,000 people. But if a megathrust occurs closer to the surface, the toll could be much greater. Megathrust earthquakes occur when one of the Earth's plates subducts or plunges under the other. If the plunging plate becomes stuck against the upper plate, the pressure builds until the lower plate suddenly and catastrophically releases, and a huge megathrust earthquake occurs. Widely thought to be the largest earthquakes the planet can generate, they often measure 9.0 or more on the Richter scale. And if one should occur on land, in a populated area, what then? Welcome back to Tokyo, home to over 12 million people who live in a megathrust fault zone. Some 100,000 people died in the Great Tokyo Earthquake of 1923. The fault is overdue to slip again. Magma is pushing the Philippine Sea Plate and the Pacific Plate under the Eurasian Plate, once thought to be 24 miles below the surface. We now know that the tops of the plates are actually less than 3 miles down. That's why earthquake experts call Tokyo a city waiting to die. When the big one hits, will Tokyo be level? Tokyo's geological nemesis could generate a tsunami of immense proportions. But it turns out it's not just earthquakes that can trigger a mega tsunami. Lying below the waves off the beautiful coast of Hawaii's Big Island, just out of sight, lie piles of rubble that extend miles out to sea. Apparently, that rubble didn't get there gradually. Instead, part of the giant Mauna Loa volcano may have collapsed catastrophically into the sea some 100,000 years ago, creating a mega tsunami that rebounded on the islands. Reaching a height of nearly 1/3 of a mile, the waves swept inland, tossing coral 1,600 yards up on the great volcano's flanks. It would have dwarfed the tsunami of 2004. Off the sheer cliffs of Maui, even more rubble lies underneath the sea, evidence of an even bigger landslide. Apparently, these happen every 200,000 years or so. So nothing to sweat about now, perhaps. But Hawaii isn't the only place where giant volcanoes are breaking, eroding, and leaning dangerously out to sea. This is the island of La Palma in the Canaries. In 1949, the southern volcano on the island erupted, cracking off a huge chunk of the volcano's western half. Eventually, that western flank could give way, hurling an area 3 times the size of Paris a mile thick into the Atlantic Ocean, pointing straight at North America. What could happen when the volcano on La Palma collapses? Some scientists predict a wave far bigger than anything ever witnessed in modern times. The resulting mega tsunami could send a wave 20 stories high, racing across the Atlantic at the speed of a jetliner. Up to 8 stories of water could crash into the east coast of the United States, swamping Boston, New York, and Washington, D.C. in quick succession, before heading down the coast and inundating the Caribbean islands. It's hard to imagine that the Earth could have worse in store for us, but it does, and some say it's overdue. There is no landscape quite like this one. Here, more geysers erupt than anywhere else in the world. This is the world's first national park, Yellowstone. But America's most popular tourist attraction is also a time bomb of unimaginable proportions. Something so deadly, it could conceivably bring civilization to its knees. The earliest geologists to visit Yellowstone understood that all of this beauty had uneasy geological underpinnings. But many speculated that because no volcanic peak or crater was visible, Yellowstone did not represent a threat. That's because they were looking at Yellowstone from the ground. Pull out from Yellowstone to a satellite view, and something awesome and frightening becomes clear. Almost the whole park is a volcanic crater, or caldera, roughly 50 miles in diameter. Yellowstone is one of the rarest and most terrible geological phenomena on Earth, the supervolcano. It turns out that Yellowstone, like Hawaii, is a hotspot with a plume of magma welling up from the mantle. Also like Hawaii, Yellowstone is always active on some level. Witness its magnificent sound and light shows. But unlike Hawaii, when Yellowstone blows, it really blows. Right now, the magma beneath the surface causes Yellowstone to breathe. The land here rises and falls, often by a couple of meters. Scientists predict that one day this bulging molten lava will burst through the Earth's crust. It's just a question of when. Yellowstone seems to erupt pretty much like clockwork every 600,000 years or so, and it last went boom about 640,000 years ago. Uh-oh. The last eruption of a supervolcano was in Toba, Sumatra, 74,000 years ago. It was 5,000 times greater than Mount St. Helens and may have changed life on Earth forever. So much ash was hurled into the atmosphere that it obscured the sun. Everywhere in the world, global temperatures could have plunged. The rain would have been so poisoned by the gases that it would have turned strongly acidic. Plant life all around the world may have suffered. Man may even have been pushed to the edge of extinction, the population forced down to just thousands, which could explain our lack of genetic diversity. What if Yellowstone were to go today? Would humanity survive? No one really knows. The good news, though, even if mankind were blown to smithereens, the Earth would continue on as a living, breathing organism in its own right. The demolition derby of continents would continue unabated. Thanks to the momentum of plate tectonics, we can run time forward and get a glimpse of a possible future. If all continues on its current course, we may see California sailing away into the Pacific. The Pacific Ocean shrinks as the Atlantic grows to dominate the planet. Africa charges northward, squeezing the Mediterranean shut, crumpling the Italian boot, and sending mountains soaring from Paris to India. Australia crashes into Asia, the Red Sea parts, and becomes a new Atlantic-sized ocean. How high can Everest go? Everest continues to grow even taller, but scientists think it will likely begin to crumble under its own weight. Clearly, this is a dangerous planet we found ourselves on, thanks to the magma machine we skate on and its tendency to push, pull, and explode. But what to us is disaster upon disaster is another thing entirely to the Earth itself. The lava-driven world is a living, breathing, mobile organism in its own right, full of stresses and strains, always seeking peace and equilibrium despite its internal conflicts. Volcanoes release internal heat. Earthquakes relieve stress on its surface. Life may well have been born of lava, perhaps on some chemical wonderland created by smokers under a primordial sea. It almost certainly owes much of its diversity and hardiness to the plate tectonics that drives continents apart and smashes them back together again. Without lava, the world would be a cold, characterless stone in space. Instead, it blesses us with oceans and renews the surface of the Earth with rich, fertile land. Unknowing, unmoved, it moves us and holds our fate in its hands, glowing fingers and glowering fists.